Good day. I will be discussing quiz number 1, version 2. It is version 2 because it is an improved version of quiz number 1. The content of this PowerPoint was made through the help of Dr. Edwin R. Arboleda, Doctor of Engineering. I am Mark Ryan B. Hermogino from BSECE 3-1 with student number 2019-11100, and I will be reporting the quiz number 1, version 2. So, first, let us recall what is WICA. WICA is a collection of machine learning algorithms for data mining tasks. It contains tools for data preparation, classification, regression, clustering, association rules mining, and visualization. Found only in the islands of New Zealand, the wika is a flightless bird with an inquisitive nature. The name is pronounced like this and the bird sounds like this. Wika is an open source software issued under the GNU General Public License. An exciting and potentially far-reaching development in computer science is the invention and application of methods machine learning (ML). This enables a computer program to automatically analyze a large body of data and decide what information is most relevant. This crystallized information then be used to automatically make predictions or to help make decisions faster and more accurately. So now let us proceed to the main focus or topic of this video, which is improving the dataset. We have already submitted a quiz number 1, and now we will be improving the dataset and producing a version 2 of the quiz. Now, improving the dataset. Here is the original Excel file which is passed to us by our professor. Title of Excel file, the name is Dataset September 23, 2021. Here is the original Excel file. This is what it looks like. Here are two types of cacao, Trinitario cacao. Here you can see the Trinitario cacao. You can see blank spaces on the left, and at the rightmost column, there is no title or there is no headings for the numbers 11111 that indicates it's a Trinitario cacao. So maybe this is the error. Let's try to find the error. Now, this is also part of the original file, the second type of cacao, the first type of cacao. Here we can see we have 250 samples each class. Now let us proceed to the encounter error. After converting the Excel file into CSV file and trying to open the CSV file into the Wika application in order for it to convert into ARFF file, a problem has been encountered. So we are here in the Wika application trying to convert the CSV file into ARFF file. However, a pop-up window saying that error loading file. It indicates that java.io IO exception index 24 out of bounds for length 24 problem encountered on line 2. So we have an error. We're facing an error on line 2. Let's now try to fix the dataset in the Excel because there is an error in the original file when trying to upload it in Wika. So this is now what we will improve because there is an error. Next. We are now trying to fix the Excel file in quiz number 1, which we have submitted. This is the fixed file that we have been submitted past week ago. So what we have done in the Excel file, the fixed Excel file, is that on the left side, leftmost side of the Excel column, we have typed the name of the Trinitario cacao and place a name of Trinitario cacao and Forastero cacao. So there are 250 samples. We have typed 250 names of Trinitario cacao and Forastero cacao each. So I have diagnosed the problem. I have seen that the name Trinitario cacao and the class 1111 are just the same. So it is like doubled. That is why we are getting 100%. So it seems like the problem is with the name and class. That in my previous quiz, it seems like they are already doubled and we should only edit one column. So here we can see the name Trinitario Cacao and then the class number 1. So this is the previous fixed file. We can see now the Forastero Cacao, which is denoted by class 2. Here this is also part of the fixed file on quiz number 1 before. Now, we tried to open the fixed file before in Wika and it is working. We can now open it without an error because before quiz number 1, when we are trying to run it on Wika, we encountered several errors. Now, I already opened the file in Wika. It shows that there are 2 labels, the Trinitario Cacao and Forastero Cacao. But it seems like there's also another minor error for the count of Trinitario Cacao. There are only 245 samples read by the application. It's weighted also 245. It must be 250 each class. But I think it's just minor error. So we can now see the Trinitario Cacao and Forastero Cacao dataset in the Wika. This is from quiz number 1, version 1. So we can see here two black images. Let's click on visualize all. Here, in the uppermost left corner, we can see the 2 black images. And we can see the plot, the diagrams or the graphs in while we are visualizing it. We can see it in black and white. The graphs and tables are only in lines of black and filled with white color. Okay, next. Now, let's try to classify the previous file. It says that what I got from the previous quiz is the highest producing percentage of accuracy is from the lazy folder under the lazy folder, and the classifier is named as LWL. It gives me a correctly classified instances of 495 with 100% accuracy. So it's too good to be true. It means the data might have been over manipulated. So what I have explained earlier is that the possible cause of this must be the class is doubled. That there is already a name for Trinitario Cacao, and there's also a class represented by 1 and 2 of Trinitario and Forastero cacaos. So it might have been doubled. But let us still check. So here, the 100% is said to be over manipulation by our professor. Now, we are asked by our professor to improve this output, the results of this quiz number 1. And now we will now proceed to the next steps of improving the quiz number 1. So let's first see the other results of the quiz 1. Here are the other results. When we click visualize, here are the plot matrix. Finally, we will now improve the Excel file in quiz number 1. It will now be the version 2 of the quiz number 1. Okay, let's try to fix the file. Here is now my new output named quiz number 1 version 2. So what I have done here is that I removed the Trinitario cacao and Forastero cacao from the left side and placed it in the right side of the Excel file. Instead of putting 1 and 2, I named it Trinitario cacao and Forastero cacao under the name of class. I have put class and changed the numbers into names of Trinitario Forastero cacao because if it is numbers, the Wika will detect that it is numeric. And if it is numeric, we cannot get the correctly classified instances. So we need to produce a name or letters involving alphabets. So we can see if the class, so we can run the correctly classified instances. So here, what I will repeat, what I have done is that I placed the Trinitario cacao and Forastero cacao, each for the 250 samples. I put their names, and then I put them under the new column of class. So here's the Trinitario cacao class, and this is the Forastero cacao class under the highlighted section or row. This is the column for the Forastero cacao. I changed the 2 into Forastero cacao and 1 for Trinitario cacao. Okay, let's now see what happened. Now, the improved CSV file in quiz number 1 version 2. So I will be saving now the Excel file that I have tried to improve to a CSV file. Here's now the CSV file. We can now see that it had been saved into a CSV. So that was the Trinitario cacao, and same for here, the Forastero cacao. So we have made changes. Now let us trying the improved file in Wika. Now let us try to run the CSV file if we will not encounter any more errors in opening it in Wika application. Now, first, let us open the Wika application. Let's go to the Tools tab and then open the CSV file. Now, let us click on the CSV file that we have saved earlier for the quiz number 1 version 2 improved file. Now, let's open. Yay! We have successfully opened the CSV file without any errors. Here is the preview of the CSV file in Wika. So all is good. The class, here we can see at the rightmost column, the class that we have edited. And now we will save it into an ARFF file so we can perform it in the classifier for later. Okay, let's now save it into the ARFF file in the same folder. Okay, save. Now, let's go back to the homepage of Wika and click on the Explorer application. We will now be directed to a new window, and here we will now open the ARFF file we have just created. So let's now open the ARFF file. Open. This is for quiz 1 version 2 improved file. Now we can see that there are difference in the results. It feels like we have really improved the file. You can now see that. Let's try to visualize the plot, diagram, or graphs of this data set. Okay, we can now see the mean, the standard deviation. Let's now try to visualize all. Now, we can clearly see that it had made difference. First, there is no black, the two black, big black box from the previous quiz number 1. Now, in the quiz number 1 version 2, we can see the plot or diagrams that it has two colors, red and blue. The previous one is only black and white. So it seems that it really has been improved. Here is the black and white. Here is the red and blue, or the colored version of the graphs. So it is now close to the what we are looking for. So this is the visual. We are visualizing the graphs with colors. Now we will go to the classify. Let us set the folds, cross-validation folds, into 5. Because there are 500 samples, 250 of each class. There are 2 classes. Now, if we divide 250 into 5, we will get 50. That 50 is the 20% of the samples. We need to get the 20% of the samples. So 50. So the cross-validation folds will be 5 because the 80% or the 200 will be used for training, and the 20% or the 50 will be used for testing. So let's put the cross-validation folds into 5, and let's try to classify it with the default classifier in the Wika, which is 0R. It says that classifier for building and using an OR classifier predicts the mean for a numeric class or the mode for a nominal class. Capabilities, class, binary class, data class, missing class values, nominal class, numeric class. Attributes, binary class, attributes, data attributes, empty nominal attributes, missing values, nominal attributes, numeric attributes, relational attributes, string attributes, unary attributes, interfaces, sourceable, weight, distance handler, and additional minimum number of instances 0. So we can place our cursor in each of these classifier to see what is the most suitable classifier for our data set, because it can provide a description or information about the classifier we have chosen. So let's first try the default 0R classifier. It says that correctly classified instances is to 50, which is 50.51%, and the incorrectly classified instances is 245, which is 49.49%. So it seems to be correct. Now, let us go to the Select Attributes tab, and we will be choosing or ranking the attributes. Here we can see the selected attributes 5, 6, 8, 11, 16, 20, which are 6 main attributes: the W, var, M-axis, D, H, and ENT. here are the most needed or most valuable attributes from the class. There are 6 main attributes or features that needs to be selected. So we will try to rank it through the attribute evaluator. Let's now choose InfoGain attribute eval. This is a attribute evaluator for ranking the attributes. InfoGain attribute eval evaluates the work of an attribute by measuring the information gained with respect to the class. InfoGain attribute equals H class minus H class attribute. Capabilities, class, binary class, missing class values, nominal class. Attributes, binary attributes, data attributes, empty nominal attributes, missing values, nominal attributes, numeric attributes, unary attributes, additional minimum number of instances. So we will click on the InfoGain attribute eval. And now we will click the search method for ranker. Ranker ranks attributes by their individual evaluations, used in conjunction with attribute evaluators, relief, gain ratio, entropy, etc. So we need to choose ranker to evaluate the rank of our datasets, of our features or attributes. So the num to select must be in -1 for the ranker in order to rank it from top to bottom. Okay, not it is correct, -1. So let us click OK. Here we can see the attribute selection on all data input. We have now the attribute ranking. Here are the rank attributes. We have here the highest we have is from W of it is ranked 0.195, followed by 1.185 by M axis. Next, 1.1617 by ENT. Next is 1.537 by D. Next is 1.411 from area. And next is 0.0981 from H down to G, S, D, standard deviation, V, RAR, E, AR, L, M axis, and so on. So here are the rank attributes. We have seen earlier the 6 most needed attributes. Now here's the complete ranking of the attributes. That we can now see the the most important attribute is coming from W. Now, next is the area. HG is the VRAR, EVAR, cont, L, M axis, S, peri, homo, K, and RB sample. So there are also attributes which ranked 0, which means it it is not necessary at all. So the selected attributes rank is from 5, 8, 20, 11, 2, 16, 14, 19, 18, 12, 7, 22, 4, 9, 17, 3, 23, 10, 21, 15, 13, 1. We have now total of 23 attributes or features. Now let us try to classify the data set, the new improved data set from our quiz 1 version 2. Let's try different classifiers. First, let's try BSNet under BIAS. So we can see here a correctly classified instances of 346 with a 69.899% and incorrectly classified instances of 149 of 30.101%. That is from BIASNet classifier. Let's try the naive Bayes multinomial. It has correctly classified instances of 287 with 57.97.98% and incorrectly classified instances of 208 with 42.0202%. Next is the naive Bayes multinomial text with correctly classified instances of 250 with 50.5 50.5051% and incorrectly classified instances of 245 with 49.4949%. Let's try the 1R from another classifier. The correctly classified instances 297 with 60% and incorrectly classified instances with 198 or 40%. Next, let's try part with correctly classified instances of 355 with 71.7172% and incorrectly classified instances of 140 with 28.2828%. Now, we are getting low accuracy from these classifiers, but we haven't tested it all. We will test it all later. Now, before doing that, let's go to the attributes. From the Select Attributes tab, the info we have gained from the ranking or the ranker, here are the 7 attributes or features that rank 0. I think it is not more needed in our data set. The Perry, Homo, K, and ENR, R, B, and sample. All of these 7 features are ranked 0. So we will try to remove it. We will go to the Pre-Process tab. Here in the Attributes section, we will click the sample, Perry, K, B, R. You can see here with the check mark in the box. KBR, ENR, and Homo. We will now check these boxes. And we will now remove these attributes or features from the dataset because it ranked 0. It means that it does not contribute anything at all in the dataset. Or maybe it has minimum, or it produce incorrect classified instances for the dataset. So we will now check it and remove it. Remember that do not remove the class because the class is very important. It is what we are using in the classifying, and it shows the Trinitario and Forastero cacao because it is non-numeric. It is in words, and this is the only class that we can classify with the help of this class. So let's go back to the attributes or features that we will remove. We will remove those features, and now we get a new results for our data sets. Now let's go back and classify these data sets. First, let us take a look of the new diagrams or graphs. This is the visualizing tab. Now let's classify it into a new type of classifier under SGD text. It says that correctly classified instances are 250 at 50.5051% and incorrectly classified instances at 245 at 49.4949%. So let's try more classifiers. Here we can see the multi-layer perception at correctly classified instances of 430 at 86.8687%. The incorrectly classified instances is 65 at 13.1313%. It is high. The 86% is high, but what we are looking for is 90%. Because we are tasked to do is to choose a classifier that will produce the highest accuracy, but not 100%. So our goal is to choose a classifier with 90% above accuracy. It means high accuracy. It is the best classifier for this data set. So let's try to look for classifiers with 90% above. So let's try SGD. It says that correctly classified instances is 407 with 82.2222%, and incorrectly classified instances is 88 with 17.7778%. Close to 90, but let's see for 90. Let's try the functions of multi-layer perception. The correctly classified instances is 489 at 98.7879%, and the incorrectly classified instances is only 6 at 1.2121%. So this might be what we are looking for, because it is not 100% and it is greater than 90%. And it is very high because it produces a 98%, which is high accuracy. And it might be the best type of classifier for this kind of data set. But let's take more look on the other classifiers. Maybe there are also some 98 or higher than 98, maybe 99. But let's take note of the multi-layer perception. For now, I can conclude that this is the best classifier for this dataset because it produced the correctly classified instances of 489 and a percentage of 98.7879 accuracy. Let us remember multi-layer perception. And the time taken to test model is also at 0 seconds only. It means it's fast, it's efficient, and it is accurate. Multi-layer perception. Now let's go for more classifiers. Let's try to click the attribute selected classifier. Correctly classified instances is 446 at 90.101%, and incorrectly classified instances is 49 at 9.899%. So this classifier also reached 90% accuracy. So it is also included in the classifiers we are searching for, but it is a little lower from the multi-layer perception, which is 98%, which is still the better classifier. So let's take more. Here we can see the under the lazy function or the lazy tab folder of LVK. We have gotten a correctly classified instances of 495 at 100% and incorrectly classified instances at 0%. So after what we have concluded in our observation from the past data, we can say that this classifier that produces 100% is overly manipulated. So we will not be using this classifier because there is an over manipulation of data. So let's skip to this. Next, let's try LBK from metabagging. And let's try metabagging. Correctly classified instances is 443 at 89.4949%, and incorrectly classified instances is 52 at 10.5051%. So it is very close to 90 because it is 89%. Almost. Only a matter of 0.5% difference and it will become 90. So this is almost. Look, we also got another 90 from meta attribute selected classifier. It has correctly classified instances of 146 at 90.101% and incorrectly classified instances at 49 at 9.899%. So this is 90. it satisfies what we are looking for 90% above and higher. Another 90% from meta-random subspace. Correctly classified instances of 449 at 90.7071% and incorrectly classified instances of 46 at 9.2929%. Yes, we got another 90%. This is good. We are getting good results from the classifier, from our improved version. Next is the rules part. And it has a correctly classified instances of 460 at 92.9293% and incorrectly classified instances of 35 at 7.0707%. So it is slightly higher than 90% because it is 92. So it is a good classifier. Next, let's go to trees. Trees folder, and the name of classifier is J48. The correctly classified classifier instances for the classifier of J48 is 468 samples at 94.5455%, and the incorrectly classified instances is 27 at 5.4545%. So this is, as far what we have reached, this is the one next to the multi-layer perception of 98%. What's next to the 98% is the 94% from J48. So this is the second best classifier, the J48, because it also has a high classifying, high correct instances and high accuracy. It is also at 0 seconds. So time is important in comparing the data because this is the time taken, how long it takes for the classifier to process the data. So the faster, the better, because it will produce efficient results. So now, let's try to visualize the plot matrix. Here are the data for the class Homo. The sample area for here are the datas for the dataset. Now let us remember that what the best classifier so far we have gotten is from multi-layer perception at 98%, and next to it is the J48 at 94%. So the best, most accurate, most efficient, and the fastest is from the multi-layer perception at 98%. Now we have seen the results, and we can now close the Weka application. Are you sure you want to close the window? Yes, because we are finished with the quiz number 1, version 2, the improved version of the previous quiz number 1. I hope you learn a lot from this discussion. Here are my references. The YouTube channel of Edwinus Prime. Here's the link, and more references if you want to learn more about Weka operation. So here you can watch again the video, and I hope you have learned a lot from me. Thank you for watching, and God bless. This is the quiz number 1 version 2, the new version and improved version. I am Mark Ryan B. Hermogino from this BSECE 2-1 with 2019-11100. Again, thank you. and God bless. Have a nice day.